Welcome to the deep dive. Our mission today is, well, it's really about finding the signal in all the noise. We aren't going to look at 1,000 different market reports. Instead, we're taking one single strategic business decision.
A really specific one.
Exactly. By a massive player in the semiconductor industry, Micron Technology. And we're using it as a lens to understand the real gravitational forces shaping the global economy right now.
It's the kind of move that, it doesn't generate these huge, loud consumer headlines.
Not at all.
But if you look closely, it just screams volumes about resource allocation, about technological priorities. This isn't just a small shift in a product line.
No.
It's a strategic abandonment of one legacy in favor of an entirely new future.
That's exactly right. We've been tracking this huge transition, and the question we're exploring with you today is pretty stark.
Yeah.
How does a company built on mass market accessibility decide to, well, effectively stop catering to the everyday consumer? And what does that tell us about the unstoppable rise of the AI economy? This single-choice Micron's pivot, it acts as a perfect case study.
Yeah.
It's a snapshot of this profound reorientation of industry, technology, and capital.
And what the strategic exit really illuminates is the the non-negotiable pull of specialized computation.
Non-negotiable. That's a great way to put it.
Yeah, the traditional business model of, high volume, low margin, serving billions of people, it just can't compete anymore.
It can't.
Not with the high value, highly specialized demands of this centralized AI infrastructure.
Okay, so let's unpack this and really get into the detail. Our objective here is to treat Micron's choice as a snapshot, a compressed view, to fully understand AI's comprehensive impact on traditional markets and, crucially, the underlying economics of processing power.
Right.
We're going to show you how the sheer physics of computation is now dictating global corporate strategy. It's fascinating.
It really is.
So to truly appreciate the magnitude of this shift, we have to first establish the scope of what Micron is walking away from.
Yeah, you have to know what they built.
They are a true titan, but their origins were anything but cosmopolitan or predictable.
Oh, not at all. And understanding their roots, I think, really highlights the weight of their current decision.
How so?
Well, it takes immense institutional fortitude and often, a real technological necessity to turn your back on the very foundation that made you successful in the first place.
So let's talk about that foundation. Micron Technology was established in 1978. Now, you have to think about that time frame for a minute.
Right.
That's well before the widespread adoption of the IBM PC. It was the absolute dawn of the personal computing era. Memory was still largely custom-built, highly specialized stuff.
It's the pre-commodity age. That's the key. They were pioneers. They helped define the standardized memory component, the DRAM, that would eventually become the fundamental building block of every single computer on Earth.
So they weren't just following a trend.
No, they were laying the groundwork for the modern digital economy we live in now.
And the setting for this revolutionary work, Boise, Idaho.
Yeah. Which just underscores that innovation isn't always confined to, the coastal hubs.
And they didn't even start as a chip manufacturer, right?
Right.
Our source materials note they began as a small design consultancy.
Launched by a group of engineers described as visionary. They were just solving these highly specialized memory design problems for very early computing systems.
That term, visionary engineers, you don't think that's just PR speak?
I don't think it's hyperbole here. I think it suggests they understood really early on that memory, which was often an afterthought in the early days of microprocessors, would eventually become the bottleneck.
Okay.
And therefore, it would become the strategic component. So their entire foundation was rooted in finding these specialized solutions, which is, it's incredibly ironic considering the direction they're going now.
It really is. And speaking of roots, the most incredible anecdote about their start, and this one perfectly frames the shift from traditional industry to high tech, is where their initial money came from.
Yeah.
It wasn't just venture capitalists.
No, it wasn't. This detail is just pure American industrial history. To get off the ground, Micron relied on local investors, and the source highlights a notable contribution from the famous agricultural titan, the potato magnate J.R. Simplot.
The potato magnate. It sounds like the premise for a TV show.
Right.
But it's a profound historical data point. You have Simplot, whose entire wealth was founded on a physical, tangible, universally consumed commodity, the humble potato.
Yeah, a potato.
Investing heavily in the ultimate intangible digital commodity, the memory chip.
And that symbolizes the whole transition of American enterprise right there.
Exactly.
You have these traditional, stable, cash flow generating industries pouring their wealth into this futuristic high-risk sector.
Yeah.
And that backing gave Micron these deep, stable roots. It allowed them to scale up fabrication and eventually evolve from a small consultancy into the semiconductor powerhouse they are today.
And that stability, that's what allowed them to serve the mass market. For decades, Micron's purpose was all about volume.
All volume.
Serving the massive consumer technology complex. The PCs, the servers, the mobile devices, the gaming consoles. They optimized their entire operation for ubiquity and reliability to satisfy a global population of individual buyers.
They basically optimized for the Simplot customer base, the common consumer.
Right.
They became experts at producing huge volumes of standardized components like DDR DRAM and consumer-grade NAND flash. Their entire supply chain, from sourcing silicon wafers to the final testing, was tuned for price competition and accessibility.
And that is the 4-decade legacy.
The whole thing.
That is now being strategically reevaluated.
Yeah.
Which brings us to this moment of fracture. So a company built on this foundation, powered by consumer volume, makes a deliberate, strategic decision. Micron is executing a clear, quote, strategic exit from the consumer market.
And this is not just trimming the fat from a single unprofitable line. I have to emphasize that.
Right.
This is a foundational directional shift. When a company of Micron size uses the phrase strategic exit, it signals that the entire allocation of future capital expenditure, R&D talent, manufacturing capacity, it's all being prioritized elsewhere.
They're essentially starving the consumer segment of resources.
Intentionally, yeah.
And where are all those resources being diverted? The new focus is entirely on these high-demand, high-performance sectors. Our analysis confirms their pivot is to sectors dominated by AI and cloud computing.
Which immediately tells us who's commanding the market. The hyperscalers.
The big guys.
The biggest. These are the cloud giants, Amazon's AWS, Google Cloud, Microsoft Azure Plus, major players like Meta and OpenAI, who are all building these vast, centralized computing infrastructures.
And they aren't buying a few thousand chips.
Oh, no. They are placing orders for millions of highly specialized, high-margin components.
So the whole model changes. The shift is from selling, say, 1 million standard sticks of DRAM to 1 million individual consumers, to selling 1 million units of highly specialized memory to maybe 4 or 5 major cloud providers.
It fundamentally changed the sales model, the R&D cycle, the economics of scale, everything.
And I guess the opportunity cost of continuing to dedicate precious engineering and fabrication resources to commodity consumer products is now just staggering.
It is. Why would you? Because consumer chips are high volume, but they're low margin and incredibly competitive.
A race to the bottom on price.
Exactly. Whereas the specialized AI components, on the other hand, they're high value, high margin, and they demand cutting-edge manufacturing processes that utilize the full capacity of a multi-billion-dollar fabrication plant.
So the profitability and the strategic necessity of supplying the AI economy just completely overshadows the traditional consumer business. It's no longer a sustainable dual strategy for them.
Exactly. And when you factor in the technical specialization required, which I know we'll get into, the decision to abandon the consumer market becomes less of a choice and more of an economic compulsion.
Look, compulsion.
They are prioritizing the needs of centralized computational power over broad consumer accessibility. The weight of this decision is clear. It represents a pivotal shift in the semiconductor industry itself, and it validates the overwhelming economic power of this AI infrastructure race.
It's the ultimate irony, then. The capital born from the physical commodity for the masses, potatoes, created the digital commodity for the masses.
Consumer memory, yep.
Only to have that digital commodity now rerouted and reserved for the specialized needs of AI.
That's the story. And this pivot really has to be understood through the lens of pure technological necessity.
Right.
The decision to exit the consumer space isn't just about maximizing profit, though that's certainly the result. It's about meeting physical and computational requirements that consumer-grade technology it doesn't face.
It's the engine driving the train. If the engine requires a new proprietary kind of fuel that is immensely costly and difficult to produce,
Right.
the company that produces the fuel has to focus all its resources there.
Perfectly put. Our sources confirm that AI technologies are advancing at breakneck speeds, but let's define what that speed actually entails in practical terms. It's not just faster clock speeds. It's exponentially larger models.
We're talking about large language models,
Yep.
generative AI systems. The parameter counts are just soaring. Hundreds of billions, soon to be
And
trillions.
every single one of those parameters requires memory access and manipulation during training and during inference. Every single one.
And this leads directly to the specific need, right? The profound and ever-growing demands of AI technology for memory resources.
It does. The bottleneck in advanced computation is rarely the processor itself anymore. It's the speed at which you can shuttle data from the memory to the processor core. We call this the memory bandwidth problem.
Okay, so help us conceptualize the scale difference here. If I'm running a consumer-grade computer and I've got, say, 32 gigabytes of DRAM, what is an AI cluster demanding in comparison?
Well, you might have that 32 gigabytes of DRAM running at a relatively high speed, but it's still pretty far away from your CPU or your GPU physically on the board.
Right.
An AI training cluster might involve thousands of specialized accelerator chips, like GPUs. Each of those GPUs needs its own memory right next to it. We're talking hundreds of gigabytes or even terabytes of specialized memory, all running continuously, 247.
A requirement is explicitly memory to support complex AI computations.
Yes, especially things like simultaneous matrix multiplication that involves crunching billions of data points in parallel.
Right.
Can't have any delays.
So this is where we need to introduce the concept that is driving Micron's entire pivot. It's this thing called HBM.
High bandwidth memory. Yes.
This is the key technical difference that's forcing the economic shift.
Absolutely. The need for HBM is driven by that analogy you mentioned earlier. AI has an insatiable appetite for processing power and storage.
And insatiable really feels like the right word.
It is, because as soon as you feed the system with more memory bandwidth, the models immediately grow larger to utilize it. It's a cycle that never ends.
Let's dedicate some time to defining this HBM difference, because this is where all the resources are being pulled. So standard DDR DRAM, the stuff that powers our consumer devices, that's typically a two-dimensional architecture, right? A single layer of chips spread out across a circuit board.
Yeah, think of consumer DRAM as a large, sprawling city block. It's accessible, it's spread out, relatively easy to navigate. But if you need to access every building simultaneously, you have to travel across a wide area.
And that travel time is latency.
Exactly. That travel time is latency. And consumer applications, they can tolerate a little bit of latency. It's okay.
But the AI environment, performing billions of calculations a second, it just can't afford that travel time.
It absolutely cannot. And HBM solves this by taking those memory chips and stacking them vertically, like building a skyscraper right next to the brick.
That's great.
We're talking about stacking up to 12 memory dies on top of each other and connecting them through these tiny, high-speed vertical pathways. They're called through silicon vias, or TSVs.
So instead of a city block, you have this immense multi-story memory tower sitting right next to the processor.
Precisely. And this stacked architecture drastically reduces the physical distance the data has to travel. So you get orders of magnitude higher bandwidth than traditional DRAM.
Give us some numbers.
Okay, so standard DDR5 memory might offer bandwidth in the tens of gigabytes per second. HBM3 can offer bandwidth in the terabytes per second.
Terabytes.
Terabytes per second. It's a monumental difference. And that speed is absolutely non-negotiable for large-scale AI computation.
I'm just trying to wrap my head around the complexity of that stacking process, the fabrication, the packaging. It must be incredibly difficult and expensive compared to just laying down flat consumer chips.
Oh, it is exponentially more complex. HBM requires advanced packaging techniques, meticulous thermal management, highly specialized manufacturing processes. The tolerances for errors are microscopic.
And that means two things, right?
Right. First, your R&D budget has to be entirely focused on solving these 3D stacking challenges. You can't be distracted. Second, the manufacturing yield, the percentage of good chips you get from a silicon wafer, is inherently lower and much harder to perfect than with standard 2D memory.
Okay, so if the yield is lower and the manufacturing is harder, the price, and therefore the margin, must be significantly higher to justify all that effort.
And that is the crux of Micron's decision. The resources, the human capital, the highly precise manufacturing equipment, the research dollars, they have to follow the demand that offers the highest return and requires the most specialized solution.
And that's the AI market.
That is the AI market. It's commanded by the hyperscalers, and they are willing and able to pay a massive premium for guaranteed high-performance HBM. The traditional consumer market simply cannot.
So this technological compulsion, this need for HBM, it has fundamentally reshaped the landscape of semiconductor economics.
Yeah.
That's a huge statement.
It is a tectonic shift. For decades, semiconductor economics rested on Moore's law making things smaller, faster, and cheaper to sell at immense volumes.
So how does the demand for HBM disrupt that classic model?
It creates a bifurcated industry. It splits it in two. Semiconductor economics traditionally balanced the enormous capital expenditure, the capex required to build multi-billion-dollar fabrication plants, against the need to sell high volumes to recoup that cost quickly.
And for 40 years, the consumer market provided that volume.
It did. But AI changes the primary driver from volume to value and specialization.
So the most valuable product is no longer the cheapest one you can produce in the highest volume. It's the most difficult one, produces the highest margin.
Precisely. So the capital investment priority shifts immediately. If you were planning the future of your multi-billion-dollar fab, are you going to dedicate that cutting-edge capacity to refining consumer DRAM, which might sell for a 5% margin in a price war?
Probably not.
Or are you going to dedicate it to producing HBM, which might command a 30, 40, 50% margin and is essentially guaranteed revenue from a handful of hyperscalers? The choice becomes obvious.
Now, that sounds less like a technological compulsion and more like just smart business. But is there a risk they could have maintained both paths? Is this truly a compulsion?
That's a critically important question. And on the surface, yes, it looks like just a high-margin opportunity. But if you look deeper, the technological challenge is what creates the compulsion.
Explain that.
The HBM race is a land grab right now. If Micron hesitated and decided to keep, say, 30% of their capacity for the consumer market, their primary competitors might dedicate 100% of their R&D and manufacturing to HBM.
Then it'd fall behind.
They would quickly fall behind on the technology curve for the most valuable product. In the high-stakes game of semiconductor manufacturing, failing to win the technological high ground in the specialized sector can make you technologically irrelevant very, very quickly.
So, the compulsion isn't just about maximizing the immediate profit. It's about ensuring long-term technological competitiveness. If you don't build the best HBM, you lose the entire AI market, which is now the industry's main engine.
Absolutely. The profitability ratio between manufacturing a highly complex, specialized HBM chip and a commodity consumer DRAM chip is so vast that the consumer segment effectively starves the company of the necessary capital for HBM R&D.
This is a drain.
It's a drain. And the source material emphasizes this, pointing out that this is more than just business. It states the shift is driven by technology-compelling industries to pivot. The sheer physical demands of AI computation are dictating that companies must meet these specialized needs or exit the core profitability race entirely.
And this technological redirection has massive implications for the end consumer, doesn't it? If Micron, a cornerstone supplier, is dedicating all its best resources to the high-value AI market, then the traditional consumer electronics manufacturers, the Dells and HPs of the world, they're going to find themselves fighting for lower priority, potentially lower quality, and certainly less competitively priced components.
The scarcity that's driven by this technological priority inherently raises costs or forces substitutions in the consumer sector. This whole mechanism ensures that capital, research, and production capacity follow the gravitational center of AI computation, and it pulls those resources away from everything else.
The AI machine is literally sucking the best components out of the global supply chain.
That's a very good way to put it.
So let's zoom out now. Micron's strategic shift is the perfect example, but it's just one company. We need to connect this to the broader global implications to understand the ripple effect this specialization creates.
Right. We have to use Micron's exit as our central argument. It's a single case study that perfectly mirrors these colossal global forces at play.
The thesis we're advancing, which is backed by our source material, is that Micron's decision is a powerful microcosm of the wider economic transformations triggered by AI. Every force, the technological demand, the economic realignment, the resource competition, it's all compressed into this one corporate pivot.
And the broader narrative is just crystal clear. This move highlights the profound impact AI is having on traditional markets. It's an explicit signal that the reliance on legacy consumer electronics is waning as the primary driver of semiconductor strategy.
So for 40 years, the driver was the miniaturization of the PC and then the mobile phone. That era prioritized small, low power, and cheap.
Exactly. And now, the new era prioritizes massive scale, immense power consumption, and extreme specialization. This divergence means the two markets just cannot share the same manufacturing focus anymore.
And the implication for traditional component buyers is stark. Companies that were built on the old volume model are facing not just technical obsolescence, but a fundamental resource disadvantage,
They are. They have to adapt or they're going to find themselves competing for scraps.
which necessitates widespread corporate realignment. Our sources say companies across fundamental industries are being compelled to pivot, they must rethink their strategies, and they need to recalibrate to meet these new demands. So what does that recalibration look like for a company that doesn't make chips?
Well, let's say you're a specialized component manufacturer that supplies, I don't know, substrate materials or advanced cooling loops.
Okay.
Your customer base is now changing. Your biggest, most profitable customer is no longer a gaming PC manufacturer. It's a hyperscaler building a server farm that requires radically different materials.
Materials optimized for what?
Optimized for extreme heat dissipation and continuous 24/7 operation, not for cost reduction for a desktop unit that's used a few hours a day.
So recalibration means redirecting research budgets, tooling, supplier relationships, everything away from the volume-driven consumer market into the highly demanding, high-value, centralized AI market.
It changes the entire competitive landscape. Competition is no longer centered on who can sell the most units.
Right.
It's centered on who can achieve the highest technical performance and secure manufacturing capacity from the specialized suppliers like Micron. When memory, which was once a commodity, becomes a strategic, high-value asset, securing that asset is paramount.
And that ensures the entire supply chain becomes tuned to the needs of the data center, not the living room.
Yes. And this shift validates that AI is not just some software phenomenon. It's a foundational industrial shift that affects physical production.
And that's vital for you, the listener, to understand.
Precisely. Micron is merely reacting to a market force. The true story is how pervasive and how uncompromising that force really is.
So the outcome of this massive industrial redirection is that this activity represents a realignment that could define the next era of technological advancement. This isn't just cyclical, it feels structural.
Oh, it is absolutely structural.
We've had the PC era, the internet era, the mobile era,
Yeah.
all characterized by broadening access to technology.
Yeah.
What makes this AI era so distinct in terms of structural change?
It's the shift from technological expansion to technological consolidation.
Consolidation.
Yeah. Previous eras were defined by decentralization, giving power and computation to the individual device, your PC, your smartphone.
Right.
The current AI era, because of the immense scale and complexity of HBM and these specialized accelerators, requires extreme centralization in massive cloud hubs managed by the hyperscalers.
So it concentrates technological capacity.
Exactly. And it prioritizes these specialized demands over democratized access to the best components.
That focus on consolidation means rules of adaptation are changing for everyone. The transformation, as our sources highlight, is a reflection of a larger shift in how industries are adapting to the demands of a digital future.
And that adaptation is purely driven by necessity. If we connect this back to Micron's decision, it raises a really important question for every listener to consider.
Which it is.
What other foundational industries currently servicing the consumer market will be forced into a similar high-demand, highly specialized strategic pivot?
Okay, we can probably extrapolate based on the physical requirements of the AI engine we just discussed. So if AI requires massive power and specialized memory, that's Micron's domain, it must also require specialized solutions for heat and power management.
Exactly. If the best HBM is produced by Micron and it goes straight to the AI server, that server also requires best-in-class power regulation chips, power management integrated circuits, or PMICs.
And those have to be capable of handling massive sustained power draw with minimal failure.
Right. And it also requires liquid cooling loops and advanced thermal interface materials, things you just don't see in a standard consumer product.
So if a company that manufactures high-end PMICs or specialized cooling substrates sees that their AI sector margins are 10 times their consumer sector margins, and the AI product requires a completely different R&D investment, they will be compelled to follow Micron's path.
It's an inevitable cascade. The physical demands of cooling and power delivery for 1,000 specialized accelerators in a server rack are radically different from those for a consumer desktop.
Totally different world.
Right. If the material science breakthroughs required to cool these AI processors are resource intensive, those resources will be pulled from the consumer market, just like the memory was. We are very likely to see strategic exits from consumer-focused power and thermal solution providers next.
So this restructuring means the very definition of a commodity is being fundamentally rewritten across the entire industrial stack.
That's it. What was once commodity memory is now a strategic asset. What was once commodity cooling may soon be a strategic asset.
The shift we see in Micron isn't a curiosity then.
No, it's the leading indicator of a fundamental structural change in global industrial priorities, and it is all being driven by the relentless specialized demand of artificial intelligence.
And that demand ultimately means that the priorities of the few, the hyperscalers running AI, now supersede the needs of the many, the billions of global consumers.
A difficult pill to swallow, but that's what the data suggests.
This deep dive has provided an astonishing look at how the decision of one semiconductor giant really illuminates an entire global economic transformation, all driven by technical necessity.
It's a powerful validation that technology, when it hits a stage of exponential growth, becomes the ultimate driver of corporate strategy. It just overrides decades of established business models.
So let's briefly recap the powerful movements we identified here. First, we established the historical foundation of Micron,
Right.
built on the stable backing of traditional wealth, that Simplot anecdote, which really emphasizes the scale of the legacy they are now strategically leaving behind.
And second, we detailed the specific computational necessity that's driving the shift, the breakneck speeds of AI, and the need for this incredibly high-performance HBM, that skyscraper memory architecture we talked about. That created a technical compulsion for specialized production that consumer DRAM just could not compete with.
And finally, we discussed the resulting economic and industrial realignment. Micron's move is the case study for a wider trend forcing foundational industries to recalibrate toward these high-demand, high-margin sectors, the AI and cloud giants, which is structurally defining the next era.
And the source material encapsulates this perfectly. It calls it a testament to the dynamic nature of technology and its ability to drive change. When the technological requirements become this specialized, the corporate response has to be specialized too.
And that brings us to our final provocative thought, something for you to consider as you process all this information. The exit from the consumer market for memory chips suggests a total restructuring of technological priorities. The high-end computational demands of AI are now commanding the specialized resources that were formerly used for general consumer improvements.
So if the best engineering minds, the highest precision fabrication capacity, and the most advanced materials are all reserved for the AI machine, what does this imply about the future quality or availability or even pricing of standard components? We are moving from an era of accessible, high-quality mass production, which was driven by competitive volume, to an era where the pinnacle of technology is reserved for a centralized computational elite.
The ultimate price of this technological transformation may be the gradual erosion of top-tier component quality and accessibility in the devices used by the general public. And that signals a fundamental shift in who technology is truly being built to serve.
Stay curious, and remember, the real story of the AI revolution is often hidden not in the software code, but in the physical industrial capacity being redirected underneath it all.
I'll catch you on the next deep dive.